What's up, Geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to look at our Unit 3 quiz review over our parallel lines and just proving lines parallel. So let's go ahead and get started. First question, we're going to look at this figure or a number cube, dice, whatever you want to call it. Any segment that appears to intersect are perpendicular. Use the diagram to answer questions 1 through 5. So name a pair of parallel lines. I chose AB to be parallel to DC, so as long as you chose two lines that wouldn't intersect, you are good to go there. Perpendicular lines, I just kept it real simple. I still kept AB, and I chose it to be perpendicular with AD. A pair of skew lines, I'm going to say AB can be skew to HD. Oops. And then a pair of parallel planes. For this one, I said plane ABF and plane DCG. And then all lines parallel to line AB, we can say line DC. We can say line HG. And we can say line EF. And then I'm just going to go back and notate my lines a little bit better. I needed to have those arrows on the edges of all of them to make sure that it was notated with symbolism correctly. Okay. Number 6, using that diagram as well to answer these questions through technically 11. So let's just say 6 through 11. So I'll have to fix that on my paper. Here we go. Two corresponding angles. For this one, I said angle 1 and angle 5. Two alternate interior angles, I said angle 4 and angle 6. Two alternate exterior angles, I'm going to say angle 1 and angle 7. And then two consecutive interior angles, angle 4 and angle 5. And then a pair of vertical angles, angle 1 and angle 3. And a linear pair, I just said angle 1 and angle 2. Obviously, you can have different examples of that, but as you're looking through what I provided, your example would just have to match that pattern for yours. In questions 12 and 13, find the measure of angle 1 and 2, and then the theorem that you used. So for the measure of angle 1 in number 12, I found that to be 87 degrees, because those are alternate interior angles. And then the measure of angle 2 is going to be 93 degrees, because that is a consecutive interior angles, where they add up to be 180 degrees. For 13, angle 1 is equal to 124 degrees. I use the alternate exterior angle theorem, and angle 2 is also 124 degrees. I use the corresponding angle theorem. Okay. 14, we're going to find the value of x. So 6x minus 11 is equal to 37 here, because those are corresponding angles. I'm going to add 11 to both sides, so I get 6x is equal to 48, so that means x is equal to 8. And then here for 15, I'm focusing on this angle and trying to figure out what this is, or set how it could be equal to that. 2x plus 9 is not equal to 142, but 180 minus 142. So that'd be 2 times x, which is 2x, plus 18 is equal to 38. And then that means like this angle right here would be equal to 38. So we're going to subtract 18. We get 2x is equal to 20. So x is equal to 10. Okay. 16 through 18, determine if there's enough information to determine if P is parallel to Q, and if they are parallel, state the converse used. For number 16, there is not enough information. These two angles are not alternate interior or alternate exterior. It's almost like they combined alternate interior with exterior. So can't conclude it for 16, but we can conclude it for 17. These are parallel because we use the corresponding angles converse. Okay, and then number 18 is also going to be yes. In this case, we use the alternate exterior angles converse. Okay, Number 19, if the measure of angle 1 plus the measure of angle 2 is equal to 180, then what is parallel to what? And then state your reasoning as to why. If angle 1 plus angle 2 is equal to 180, then line L can be parallel to line M because of the consecutive interior angles converse. Okay. 20 and 21, find the value of x. That would make our lines parallel. For 20, these are consecutive interior angles, so I'm going to add them up to be equal to 180. So 16x and 4x is 20x, and negative 5 and 45 gives me 40, equaling 180. Subtracting 40 from both sides, I'm going to get 20x equals to 140, so x is equal to 7. And then 21, these are equal to one another because these are alternate interior. So 3x is equal to 2x plus 20. And if I move my 2x to the left, I'm going to get x equals 20. Our final question is a proof. Complete the proof if R is parallel to S and angle 1 is equal to angle 3. Prove that J is parallel to K. So what I started doing is I started with my given. So given R parallel to S and angle 1 is congruent to angle 3. For statement number 2, I also, because I know R is parallel to S, that means angle 1 is congruent to angle 2. So that reasoning would be your corresponding Angles Theorem. Sorry for the bell. Once I get that, then I'm going to use some substitution and say that angle 2 is congruent to angle 3, because that's going to help me connect lines J and K. So substitution here. And now that I know that angle 2 is equal to angle 3, I can say that these are parallel lines. J is parallel to K using the alternate exterior angles converse theorem. Okay, that'll conclude our quiz review for Unit 3 so far on proving lines parallel. Thanks so much for tuning in. Good luck on your quiz, and we'll catch you next time. Bye.